is the first one in section 3. So we've written the equation, we've decided it's double displacement. Now we're going to go through and balance it. So remember, we'd put our scratch paper up here and we would put what elements are there, leaving oxygen and hydrogen very last, oxygen being the very last one. So on the left I have one sodium, or one silver, sorry. On the right I have 2. So I'm going to come back over here and put a 2 in front of the Ag. That'll change it to 2. Nitrogen now, this 2 goes through, so I have 2 nitrogens on the left. I have 1 nitrogen on the right, so I'm going to put 2 in front because the 2 will go through. That gives me 2. Sodiums, I now have 2 on the left. I now have 2 on the right. Sulfurs, I have 1 on the left, 1 on the right. Oxygens, the 2 comes through, times this through, 6. The 2 comes through, times this through, 6. So we are balanced. Okay? So let's go to the next one. I'm not going to write up the words. We're just going to talk it through. So the next one, number 2, says tin. What is tin? Sn. Okay? Plus copper 2 sulfate. Cu, and it has a +2 charge. What's sulfate? SO4. And it has a -2. So +2 -2, we just smash them together, gives, arrow, tin 2 sulfate. Well, we just said sulfate's a -2, so tin, if it's a +2, we're just going to put them together, plus copper. What type of reaction did I just write? Single displacement, good. An element, a compound, gives a compound and a new element. Do I need to do anything to balance this one? No, it's already balanced. So we can move on to the next one. The reaction type is what? Single displacement. Single displacement, so SD. Okay, the next one, number 3 coming down. Number 3 coming down. Calcium, which is what? Ca plus iodine. Okay, we got to be careful here because I is part of Braun-Hifkel that we talked about last time, which is our diatomic. So anytime we have it as an element, we have to put it in pairs. Okay? This yields calcium iodide. Now, calcium is a +2 because it's 2 in the S, it's a column 2. And iodine here is 1 away from being a noble gas, so it's going to be a -1. So I'm still going to need 2 iodines to balance out the 1 calcium. This bottom 2 right here is not because of this, but because this was a +2 and this was a -2. So I needed to add 2 of those to get 0. Okay, that's why. On the left side it's 2 because that's how that's Braun-Hifkel. Okay? All right, going on to the next one. Propane. They gave you what propane is. Let me roll this up a little bit. Propane is C3H8 plus oxygen. What's special about oxygen? It's a part of Braun-Hifkel, so put the 2. Yields, or gives, carbon dioxide, which is CO2 plus water, which we know is H2O. Okay, now on this one, I'm going to put my scratch piece of paper up underneath again, and I'm going to go CHO. And on the left, I'm going to say, okay, there are 3 carbons. On the right, there is 1. So I'm going to need to put a 3 there to change that to a 3. On the left, there are 8 hydrogens. On the right, there are 2. What do I need to do to fix that? Times it by a 4. Good. That makes it 8. Oxygen on the left is how many? 2. How many on the right? Be careful. You have 6 here plus 4 here is 10. That is correct. Okay, so how do I get 10 on the left? Put a 5 in front of it. And now we have 10 and everything's balanced. We good? Okay, let's go to the next one. Sodium carbonate. Oh, but yes, that is combustion. Sorry, I forgot to tell the type. That is combustion. Good job. What was the one above it? We didn't say the type on the one above it. Synthesis. Good. Combustion is just a C, yes. Okay, so next one. Sodium carbonate. What's sodium? Na. What charge is Na? +1. It's in the first column. Carbonate. What's carbonate? CO3. Do you know what charge it is? -2. So how many of each do I need? 2 what? 2 sodiums plus sulfuric acid. What does the acid tell me right off? I'm going to have a hydrogen, good. And sulfuric came from sulfate. Remember our Thanksgiving thing? And so that's SO4. Remember what charge it was? It's a -2, good. Hydrogen's a +1, this is a -2. How many of each do I need? 2 hydrogens, good. Yields. We are given sodium sulfate. Sodium was a +1, sulfate was a -2. How many of each do I need? 2 sodiums, good. Plus carbon dioxide, what's that formula? CO2 plus water, H2O. Okay, ooh, what type of reaction is this? Nope, it is not combustion, believe it or not. This right here actually came together and was this and quickly decomposes into that. This is like when you have your pop, okay, and you open it up and it fizzes. It's going from carbonic acid to carbon dioxide and water. If you leave that open too long, what happens to your pop? It becomes flat. That flat is because more water is being added to the syrup and it doesn't taste as good as it used to because it's being more dilute. And you're losing the bubbles because they're coming off as carbon dioxide, so you end up with a flat, watery syrup. Yeah, not too great. So this was decomposition right here, but what was the rest? So think of it, if this was plus this and then it quickly decomposed it to this, compound, compound yields compound, compound, double displacement. So we're going to put DD/D. So it had a double displacement and then it quickly decomposed. So if you have something like that and you can't really figure out what it is, look and see if these are there because that came from this. Okay? So if it's not just hot water and carbon dioxide on the product side, you don't have combustion. Okay, I'm going to do 3 other ones. You get to choose, and then I'm going to give you some time to work on this. Yes? Oh, did we balance it? Okay, quickly check. Did we balance it? 2 sodiums, 1 carbon, 1 carbon, 1 sulfur, 1 sulfur, 2 hydrogens, 2 hydrogens. 3 plus 4 oxygens is 7. 4 plus 2 is 6, plus 1 more is 7. It's balanced. Sorry, I forget that we haven't gone through that. Okay, so I'm going to have 3 more that I will do with you. The rest you're going to be doing on your own here for a minute. Number 12. Okay, so let's look at number 12. Number 12 says potassium hydrogen carbonate. So potassium is what? Okay, hydrogen is what? Carbonate is what? CO3. This was a -2, this was a +1, and this was a +1. Does it add to 0? 1 plus 1 is 2, minus 2 is 0. So we're already at 0. Okay. All right, going on to the next one. Gives, arrow, potassium carbonate. What do I write? K and CO3. K is a +1. CO3 is a -2. How many of each do I need? 2 Ks. Good. Plus carbon dioxide. CO2. Plus water. H2O. What type of reaction? No. Say it louder. Decomposition, yes. I'm falling apart. I started with one thing, I'm falling apart. Okay? Wait a minute, that sounds like getting old. It works. You get to decompose when you die, right? Okay. Balancing side to side. I can't follow this really quick, so I'm going to grab my paper and I'm going to put underneath KHCO. Whoops, I messed those two up. It should be KCHO, because remember we always end in ho ho ho, the end of the year. Because if we leave hydrogen and oxygen to the very last, then all the problem parts are usually taken care of before we get there. But if we try and start with hydrogen and oxygen, sometimes it's really difficult. Okay. Okay, so we end with ho ho ho, just like Santa Claus, the end of the year. Okay, so potassiums. 1, 2. Put a 2 in front. Now we have 2 carbons on that left side. We have 1, 2 carbons on the right side. Hydrogens, we have 2 on the left side. We have 2 on the right side. The 2 times through. Okay, oxygens, 2 times 3 is 6. This side we have 3 plus 2 plus 1 equals 6. Done. Okay? All right, 2 more. Which ones would you like to do? What kind was that kind of reaction, guys? Decomposition. Good. Okay, what one would you like to do now? Section 3 does go on to the next page too, so if you want to look on the next page, if you want to see some you'd like to do. 16. Okay, number 16. Sodium hydrogen carbonate. That's sort of like this one, only that was potassium hydrogen carbonate, right? Sodium hydrogen carbonate. Plus oxalic acid, they gave it to us, H2C2O4. Yields sodium oxalate. Sodium is Na, oxalate is C2O4. Sodium is a +1, oxalate is a, it says right here what? -2, so how many of each do I need? 2 sodiums. Okay, plus carbon dioxide, plus water. Okay, what type of reaction is this? What did I tell you about earlier? And then decomposition, good. Double displacement and then decomposition, because remember this right here used to be carbonic acid that really quickly decomposes. Okay? All right, so is it balanced? No. So we're going to go Na, C, H, and O. Did I get everything? Okay, so 1 sodium, 2 sodiums. Got a 2. Now I got a 2. The 2 comes through. I have 2 plus 2, giving me 4 carbons on this side. I have 2 plus 1, giving me 3 on this side. How can I fix that? What about putting a 2 here? That would times that by 2, right? Making it 4. See how I did that? This is why I separate it when I go to add it up, because if I don't want to mess up sodium, I don't want to mess with this one, because that's where my sodium was. But if I mess with this one, I can still get it to add to 4. You see that? Okay, let's do the hydrogen next. Hydrogen's going to get a little hot, hairy. First one here has 2 hydrogens. Second one has 2 hydrogens. Total of 4 hydrogens. Over here we have 2. Times by 2. Okay, now hopefully our oxygens work themselves out, because oxygen is in lots of different places, every single one of them, right? So 2 times 3 is 6 plus 4 gives me 10 on this side. On this other side, I have 4 plus 4 plus 2, which is also 10. So it worked itself out. Okay? All right. Oh, I won't erase the normal one. I just erased the work. Okay, so that's what we should report. Okay, another one. This, because I won't be here on Monday because I'm going to the STEM thing. And what else? What other ones would you like to do? Which one? 17. Okay, 17, we have dinitrogen pentoxide, which is what? N2, good. O5. Plus water. Plus water gives nitric acid. What's nitric acid? This is number 17. H, NO what? Nitric came from nitrate. Nitrate is NO3. Hydrogen's a +1. Nitrate is a -1. Okay, so we're going to need to balance this. What type is it, by the way? Nope. Synthesis. I'm taking two things and making one. Good. Okay, so underneath here, I'm going to go NHO. Northridge High officers. Okay, so 2, I'm going to change colors. 2 nitrogens on this side, 1 nitrogen on this side. I'm going to change it to 2. 2 hydrogens on this side. 2 hydrogens on this side. 5 plus 1 gives me 6 on this side. 2 times 3 is 6. Okay, one last one. One last one. Number 20. Okay, number 20. Rubidium nitrate. What's the symbol for rubidium? Rb. What charge does it have? +1. Nitrate. We just did that. What is it? NO3 with a -1 charge. So +1, -1 already together. Plus beryllium. What's beryllium? Be. Be something. Okay. Be. It's in the second column, so it's going to have what charge? +2. Fluoride. F. What charge? So we have a +2 and a -1. How many of each? 2 fluorines. Good. Yields. Rubidium fluoride. Well, rubidium had a +1, and fluorine had a -1. So just smash them. Plus beryllium nitrate. B had a +2. Nitrate had a -1. So I'm going to need 2 of those groups to balance it out. Okay, so down the center, RB. This is double, right? RB, N, B, E, F, O. So compound, compound, new compound, new compound. Double displacement, DD. Okay, going side to side. 1 rubidium, 1 rubidium. 1 nitrogen, 2 nitrogens. So I come over here, put a 2 in front. When I do that, it messes up my rubidiums. So I go back and put a 2 in front of rubidium on the left or right. Going on to beryllium, 1, 1, fluorines, 2, 2, the 2 comes through. Oxygen, 2 times 3 is 6. Oxygen, 3 times 2 is 6. Done. Okay, I'm going to give you 15 minutes, work on that. We're going to come back, and then we'll work on section 4. Okay, so if you need extra help, section 4. We're in section 4. I'm going to start with the first one, so I'm going to do the first 7 with you. If we have time, I'll do another 3. They will become, this packet is due next time. So if you have problems with it, you need to make sure that you come in and get help. I will not be here on Monday because I'm doing that STEM thing. You can come before school on Tuesday. I'll be here before school on Monday, but only till 7 because we take off at 7. I'll be in the Commons. Okay. All right, here we go. Number 1. This is now section where it gives you the reactants, guys, and you need to find the products. Okay, so how many have heard of in math FOIL? First, outside, inside, last. Okay, in chemistry, we get rid of the first and the last, and we just say oi. Outside, inside. Okay, so it's just oi, outside, inside. So on this first one, as we go look at this, we say, okay, where is oxygen? Oxygen's 2 away from being a noble gas, so when it combines, it's going to be a -2 charge. Hydrogen is where? What charge is it going to have? +1. Now, when we write compounds on the product side, it's always positive first, then the negative. So we're going to write H2O, okay, because we need to balance the charge. We just made water, okay? We need to make sure that if we've written down any charges, we erase them, okay? So if you don't want to erase them, put your scratch piece of paper right up to it and write on this scratch piece of paper. We're going to balance side to side. No, we need to balance it. Okay, 2 oxygens, 1 oxygen. I need to put a 2. Now I have 4 hydrogens. I need 4 hydrogens. I put this. What type of reaction is it? Synthesis. Good. Okay, this next one gets a little bit more tricky. This is where we're going to use our OI. We got a compound and a compound. What's it going to make? A compound and a compound, which makes it what type? Double displacement. Okay, so I need to either by putting my paper up, find out what each of these are. So hydrogen's a +1. Nitrate hangs together and it'll be a -1. Manganese, I have no idea, it's down the D and F, so I got to look at what it's with. Hydroxide is a -1. And manganese then, since there's 2 hydroxides, would have to be a +2. So I'm just figuring out the charges. So this one I can get from the chart. This one I can get from my polyatomics. I can get the hydroxide from my polyatomics, and I know there's 2 of them. So, because you don't put charges in a balanced equation. Okay, this would be a +2 to balance out this -2. Okay, all right, so this is where the OI comes in. Outsides go together, and insides go together. Okay, so we're going to make water, H2O. And whenever we have water, it will break down into H+ and OH-, just so that you know. Okay, outsides and insides. So inside we have manganese at a +2 and nitrate, which is a -1. So we're going to need 2 of those. Okay, I just put manganese with a +2 with nitrate. H and OH go together in water. Positive always first. Positive always first. This is double D. Okay, we're going to erase the charges, or if you've written on a scratch piece of paper, you can do that. I'm going to leave this right here for a minute because it will help us balance. Okay, I can use polyatomics to help me balance quickly. Since these stuck together, NO3 is stuck together on the other side. So I have 1 NO3 on the left, I have 2 NO3s on the right, 2 in front of that. I have 2 OHs on the left. I have 1 OH on the right. So I put a 2 in front. That puts 2 in front of those. Okay? On the left, I have 1 Mn. On the right, I have 1 Mn. On the left, I have 2 extra hydrogens. On the right, I have 2 extra hydrogens. I'm balanced. Done. Okay, if you have to go back through this and do nitrogen, manganese, hydrogen, and oxygen, you can do it that way. I was just showing you a simpler way to do it. Okay. All right. How to what? Okay, let me show you with colors. Maybe that'll help. Guys, shh. Okay, you have nitrate that's stuck together on this side. You have nitrate that's stuck together on this side. Over here I have 2. Over here I just had 1. So I put the 2 in front. Okay? Over here now, using a different color, orange, I have an OH. This splits into H plus and OH minus. Okay? So I had just 1 OH over here, so that's why I put the 2 here. Okay? So then, we'll go yellow. I look at my Mn. I had 1 Mn, I had 1 Mn. Then the last thing I looked at was my 2 hydrogens that are right here. So I had 2 H pluses on this side, and now since this 2 comes down and is in front of each of those, I have 2. So it balanced. If you don't understand that way, it is okay still to do N, Mn, H, and O and go that way. This breaks down into H and OH. You don't have to, no. You can just do it this way if you want to with the blue down the center. Okay. All right, let's go to the next one, guys. Let's keep trying. We'll get it there. Practice is what makes this work. Okay, so what type of reaction is this going to be? I have an element and a compound. Single displacement. Good. Now, this one I can find out pretty fast. This is a -2, and this was a +1. But copper has lots of different charges. If they haven't given you a charge on copper, take it as being +2, because that's what it likes the most. Okay? The copper does 2 charges, +2 or +1. +1 is unstable, so it takes +2. Yeah, single displacement. Okay, so now, hey guys, come on. So what we're going to do is we're going to switch partners. This is 2 guys fighting over a girl. 2 positives are fighting over the negative. So they're going to switch partners. So what am I going to get on this other side? CuSO4, good. And who gets kicked out? Ag gets kicked out. Okay, so that's all I have to do there. I just need to balance it now. I shouldn't have to write this one down because there's only one thing that really needs balancing. What is it? Ag. What do I need to do to Ag? 2 on the right side. Okay. Let's look at the next one. This is one that got a compound and a compound. What type? Double displacement. But I got to remember, every time I see water, it's going to split H plus and OH minus, right? So when I do my outsides and inside, I've got to know that. Yes, on this one you do. Okay, so this one is +1 -1. Remember, we're going to go outsides, which would be hydrogen and iodine, and silver and hydroxide. Okay, so what compounds am I going to make? The friendly, unfriendly acid that will eat you alive, and, yep, says hi and then eats you alive. And Ag, OH, good. Okay, so now I'm going to erase all my extra stuff. Balancing, what do I need to do? Anything? Good. 2 hydrogens, 2 hydrogens, 1 oxygen, 1 oxygen, 1 Ag, 1 Ag, 1 I, 1 I. Done. This is double. Okay, next one. Carbon compound plus oxygen. What type of reaction? Kaboom! Combustion. Okay, this is butane. This is butane. So if you've ever used butane torch or anything like that, that's butane. So what am I going to get? Anything plus O2, we usually got a combustion reaction. What? 1 carbon? That's methane. Okay. You don't do OI on this one. Okay, this one always gives you what? I told you always gives, combustion reactions always give H2O and an oxide. Here the oxide is carbon dioxide. If you don't have enough oxygen, it goes carbon monoxide. And that's bad if you have your furnace working and you don't have enough oxygen, you get carbon monoxide, get carbon monoxide poisoning, you get too much of that, you die. Okay? All right, balancing. This is one I have to take the scratch paper, put it up under CHO. CHO. Left, how many carbons? 4. How many on the right? How many? 1. So we're going to put a 4 in front of that to make it 4. Why is it not 2? Like you said, that 2 only talks, that's only the oxygen. Good. Okay, hydrogen, how many? 8. How many on the right? 2. What do I need to do? Put a 4 in front of it. Now we have 8. Okay, oxygen, left, 2. Right, we have 4 plus 8 gives you 12. 6, and that we've got 12. Done. Okay? Okay, next one. I'm just having a hard time erasing with this little one. Okay. I could. Just one more thing. What type of reaction? It's a type of double displacement. No. Those are the key things. It's an AB. It's an acid base. Good. Sorry, I didn't hear that. Okay, sorry. Selective hearing. Okay. So these two go together, OI, and then these two will go together. So I need to know the charges. So hydrogen's a +1, nitrate is a -1, hydroxide we did up above was a -1. I have 3 of them, so iron is what charge? +3. Okay, what am I making? What do I get? H2O is one of them, plus, that's my outside, what's my inside? Good. Okay. Because the charge on the iron is 3, I need 3 NO3s. Now, we've got to balance it because we can't make something out of nothing, right? So what do we need to balance? So I can do the Fe and HO. Fe11, right? Nitrogen, left. Right. 3. So how many do I need on? Good, okay, 3. Hydrogen. Oh, there are 6. I missed that. 3, so it's 3 plus 3. There's 6. Yep, so I get 6. Okay, oxygens. 3 times 3 is 9, plus 3, 12. 3 plus 9, 12. Yes. Okay. Okay, next one. What type of reaction? Decomposition. What am I going to make? Na plus O2. Why? It's a Braunhefkel. Oxygen is a Braunhefkel, so we have to have the 2. Okay. How do I balance it? Okay. NaO. So if I fix this and put a 2 here, then I have a 1 here and a 2 here. Put a 2 here. That fixes this to a 4. Okay. 3 more, your choices. 3 more, your choices. On the back page, 3 more, your choices. Now the rest of you are going to have to do it on your own. Okay, 14. We already had a 14 ask. Okay, 14. Okay, good. I heard single displacement. That is right. Okay. What charge is zinc going to take? It's part of the slide. Boron, aluminum +3, zinc +2, silver +1. Okay, what charge is gold? Have no idea. What charge is nitrate or nitrite? -1, and there's 2 of them, so gold has to be a +2. So we got 2 guys fighting over girl again. Okay, so AU gets kicked out. Who gets the girl? Zinc. Zinc has a +2. Nitrite is a -1, so you need 2 of them. Don't need to do anything to balance it. No, nothing. Done. Okay, what was the next question? Got 2 more. Which one are we doing? A single displacement. 18? 17? It is a combustion. Kaboom, what do we make? H2O plus CO2. Okay, the hardest part on this one is balancing it. Okay, which is CHO. Combustion, if it has a carbon compound, yes, it will go to H2O and CO2. If it has a nitrogen compound, it will go to H2O and nitrous oxide. If it has a sulfur compound, it will go to H2O and sulfur dioxide. So it can do other oxides, but it has to be an oxide. Okay, so let's go. On the left-hand side, how many carbons? 2. How many over here? 1. So, okay, got it. Hydrogens, how many on the left? How many on the right? So change it, make it 4. Okay, now this one I'm going to write a little bit different because it's in 2 places. How many oxygens? 2 plus 2, which is 4. How many oxygens over here? I'm going to write it the same way. 2 plus. I don't want to mess with this one because if I mess with that one right here, it's going to mess up my carbons and hydrogens. So I can mess with this one. Okay, what do I do with make it 6? Make it to add 6. Put a 2 there. That times it by 2, making a 4. 4 plus 2 is 6. Okay, that was the hardest part, is figuring that out. Okay, one more. I'll do one more.
Do 9. LIVR plus
Okay, what type? Double displacement, +1, -1. SO3 is -2. There's 2 of them, so CO has to be a +4. Okay, double displacement. Oh wait, outsides, insides. Okay, Li, SO3, but I need 2 lithiums, right, to balance a charge. Plus, cobalt is going to go with bromine. How many of each do I need of those? 4 bromines. Good job. Okay, now balancing side to side. Li, Br, Co, S, and O. Lithium. 1, 2. 2. Br. 2, 4. Oh, man. So then we go back and put a 2 here, right? COs. 1, 1. Sulfur. 2, 2. Oxygen. 6. 6. Done. Okay. What type is it? Double displacement. This packet is due next time. This packet is due next time. Okay, let's put the chairs up.